Okay, so for this video I said I would look at more homogeneous equations because I only got through one example in the last video. So for this one, we have dy dx is equal to x squared plus xy plus y squared over x squared. So, just like the last video, we want to get it in terms of y over x, right? So, how would I do that for the top, for the numerator, and for the denominator? Well, I could divide the numerator and the denominator by x squared, right? So this will become dy dx x squared plus xy plus y squared over over x squared over x squared over x squared. So this will leave us with dy dx is equal to 1 plus y over x plus y squared over x squared over 1. This will just cancel. That becomes 1. Now if you notice, we were left with y over x, right? This is homogeneous. Just like this wasn't separable. Now we ensured that it's homogeneous, so now we have to make it separable. So we're going to set u equal to y over x. We substitute it in, and let's do this real quick. Y is equal to u times x. dy dx would be u, let me think about this. First times derivative of second, yep, u plus x du dx. And then we're left with u plus x du dx is equal to 1 plus u squared. All I did was plug the u into here and the dy dx into over here. So now I'm left with this. So I subtract the u over. This cancels with this. X du dx is equal to 1 plus u squared. Now, we have a separable equation. We can separate it. So, we can do this. We'll have 1 over 1 plus u squared times du is equal to 1 over x dx. Right? Now, all that's left to do is integrate both sides. This is the natural log of 1 plus u squared is equal to the natural log of x. And just remember, we had the plus c1 plus c2. This will leave us with plus c when we combine the constants. Now, wait a minute. I've made a very common mistake. Right here, this is not correct. I've made a very common mistake. The integral of 1 over 1 plus u squared is the inverse tangent. That is inverse tangent. That's inverse tangent of u. I can't believe I did that. Well, we have inverse tangent of u is equal to ln of x plus c. That's my fault. My fault. This is correct. Anyways, Now, let's see. We can plug in for u, because we know u is y over x, right? From before, u is y over x. We're left with tan inverse y over x is equal to natural log of x plus c. And then we could just rewrite it like this. Oops, forgot that there. Minus ln of x is equal to c. This is our final answer. Inverse tangent of y over x minus natural log of x is equal to c. And don't forget your absolute values on the natural logs. Okay, example 2. Looking at this, it's not separable. So, let's see if it's homogeneous. Homogeneous? Is it homogeneous? Let's find out. We have dy dx. What can we do to make the numerator be y over x? Well, this is a trickier one. Oh, I have copied it down wrong. This should be x squared plus 3y squared. I was gonna say, I don't think that was homogeneous if it would be x cubed. I don't think you could have did that. Anyways, looks like we're gonna do the same thing as we did it for the last one. We can divide the top, yes, we can divide the top by x squared, right? And we can divide the denominator by x squared as well. So yes, it is homogeneous. We can quick simplify this. 1 plus 3y squared over 2y over x. Fantastic. That is homogeneous. So now we can make it separable with u sub. Oh, you know what I forgot up here? This is y squared over x squared. Yep, okay, so now we'll be left with u is equal to y over x, y is equal to u times x, dy dx is equal to u plus x du dx. So then u plus x du dx, so we substitute everything in, is equal to 1 plus 3u squared over 2u. Yep. And then that leaves us with, let me see, we subtract that u over. So be very careful with this subtracting the u over. I highly recommend try not to do it in your head. I have made the mistake on exams where I subtracted the u over in my head, and then I made simple mistakes or sign errors or something, and it completely messed me up. So if you're here, I highly recommend writing this out. If you subtract the u over, this becomes x du dx is equal to, that's 1 plus 3u squared minus 2u squared over 2u, right? Okay, now we can separate it. So now it's separable. So now we'll be left with 2u over 1 plus 3u squared minus 2u squared times du is equal to 1 over x dx. So now we integrate both sides. First of all, I forgot to simplify this denominator here. We can simplify this. This becomes 2u over 1 plus u squared du is equal to the integral 1 over x dx. See, this isn't a bad problem. The last video, the example I did on the last video, that was a very hard example because it had partial fraction decomp and very ugly simplification. But this one will turn out nice. So we're left with, this will become, I think we might have to do u sub for this one. Yep, we have to do u sub. We'll do a t sub. Since we already used u, we can do a t sub. We can have t equal to 1 plus u squared. dt would be equal to 2u dt. Right, so then that will leave us with integral, the two u's will cancel, 1 over t dt is equal to 1 over x dx. If we integrate this, we're left with natural log of t is equal to natural log of x plus c. So then we plug back in for t, ln of 1 plus u squared is equal to natural log of x plus c. So now we're here. From before, we know that u is equal to y over x, right? So now we have the natural log 1 plus y over x. This will become y squared over x squared, because it's the whole thing squared, is equal to natural log of x plus c. I can simplify the inside here. This would become x squared plus y squared over x squared, which honestly, I didn't have to do that. I don't have to do that. We're just going to exponentiate both sides, so then we're left with 1 plus y squared over x squared is equal to, now just remember the log trick. If you have, once again, e to the ln of x plus c, this becomes e to the ln of x times e to the c, where this is a new constant, k, right? So then this becomes k ln of x, because this simplifies to ln of x, times k. Anyways, now that we're here, wait a minute. I'm not thinking straight here. That'll just be x, because, yeah, the natural log will disappear. Yep, that's just k times x. Sorry. I'm making silly mistakes here. Anyways, now that we're here, we can solve for k, or we can just leave it like this, to be honest with you. We could rearrange this to be this would become x squared plus y squared is equal to over x squared is equal to kx. So then x squared plus y squared is equal to kx cubed, right? These are the same answer. This is just rewritten. I guess it's a little more simplified. This is, you're okay with just leaving it like this. Yep, and that's the answer.